Welcome to the IT Free Training video on coexistence of the IP4 and IP6 protocols. IP6 will one day replace IP4, but until then, the administrator may be in a situation where they need to support both protocols. This video will take you through where the process of changing to the IP6 protocol is done and what happens when both protocols are used together. To start with, I will have a quick look at the major developments and milestones of the IP6 protocol to give you an idea where the protocol is as of today. In 1994, work was initiated for a successor to the IP4 protocol. The 90s saw a rapid expansion of the Internet, and it was quickly determined that the current IP4 protocol would not have enough IP addresses to support Internet growth in the long term. In 1996, alpha code was added to the Linux kernel, still considered experimental, but operating system support was on the way. In 1998, the Internet Engineering Task Force formally announced IP6 as the successor to IP4. A lot of work had been done before this, but now officially it was announced that this was the protocol that would one day replace IP4. In 2002, Microsoft added IP6 support to Windows XP. The protocol was effectively bolted onto the operating system. This gives IP6 support, but since it was an add-on, performance was not the best. In 2005, Linux changed its IP6 support from experimental. This means IP6 was officially supported in Linux and is considered to be stable. Following this, in 2007, Microsoft released Windows Vista, and with it, IP6 was completely redesigned rather than being an add-on in the operating system. It was also made the default protocol in the operating system, so if IP6 is available, Windows will use this over IP4. Lastly, in 2008, 6 of the root name servers had IP6 Quad A records added to them. This means that IP6 resolution on the Internet is now possible. You can see after 2008, the operating systems and the Internet core DNS services are ready. So, what is holding back IP6? If I now have a closer look at the current status of IP6, it can be seen that OS support is pretty much done. Nowadays, even devices like Android and iOS support IP6. Since OS support has been available for a while now, application support has improved. It is up to the developer to make sure that their software supports IP6. It is difficult to get statistics on current software support. However, a quick look at the feature list of most applications nowadays will show IP6 support. The last point to consider is ISP support. This is where IP6 adoption has been slow. To have a look at how slow, let's have a look at some statistics. To do this, I will open Internet Explorer. Once open, I will do a search for State of the Internet IPv6. In this case, the first result is the page I want, which I will select. If you have trouble finding this page, I've left a link to it in the references part of this video. If I scroll down, this page shows statistics of how many content requests are made using IP6. This essentially means an IP6 client has made a content request using the IP6 protocol. You can see that at the top is Belgium. Notice this is 41%, so not even the top country is above 50%. Following this, notice that the USA is just above 20%. If I scroll down, notice the percentages quickly reduce. These statistics suggest that worldwide, IP6 is not being utilized that much. To understand why, I will go to Google and perform a search for IPv6 measurements. The first result is the page that I'm after, so I will select it. The link is in the references section if you cannot find it. This page gives an indication of how the deployment of IP6 for different ISPs is progressing. Notice that Comcast is listed at 40%. Different parts of the Comcast network are IP6 ready. This means if you are connected to Comcast, where you live will determine if you get IP6 or not. Notice that below this, AT&T is 51%, but Verizon Wireless is the highest at 72%. since wireless generally uses newer technology. Since wireless was generally deployed later than cable networks, this may be part of the reason for the higher figure. In a lot of cases, many ISPs are behind on IP6 deployment, as they don't wish to upgrade their existing infrastructure if it's still doing a good job of running IP4 networks. So you can see where you live and the ISP you are connected to will determine if you get IP6 or not. If I scroll down, notice the graphic of percentage of websites available via IP6 is just under 20%. This is one of the issues with IP6 deployment. To demonstrate this better, I will open a command prompt and ping google.com. Notice that the computer contacts Google using the IP6 address. So, Google is IP6 ready. If I ping facebook.com, notice also the IP6 address is used. A lot of big companies on the internet have made their sites IP6 ready. However, notice that when I ping microsoft.com, the IP4 address is used rather than the IP6 address. Since Windows will default to the IP6 protocol, when this happens, it generally means that the site cannot be contacted using IP6. The ping command will also not get a response back from Microsoft. This does not mean the site is down. It may mean that Microsoft has their network configured not to respond to ping requests. I will now run the command with the -6 switch. This will force the ping command to use IP6 only. Notice this time the request could not be resolved. This is because the Microsoft site is not IP6 ready when this video was created. This shows the next problem with IP6 deployment. A lot of big companies have made the switch, and even smaller ones, but there are still a lot of organizations that only use IP4. However, before criticizing Microsoft too much for this, remember that they have done a lot in the deployment of IP6, so they can be forgiven for not having their website IP6 ready. Assuming that a site is IP6 ready and so is your ISP, there is still another issue that may arise. To demonstrate this, I will open the admin page of my router. This router is IP6 ready and so is my ISP. If I select the Internet option, this will display my Internet configuration. This includes the username and password that are used to connect me to the Internet. This will connect me to the Internet using IP4, however, not IP6. Every router configuration is different. However, on this router, to configure IP6, I need to select the Advanced tab. On the Advanced tab, I next need to expand Advanced Setup on the left, and then select the option IP6. Notice the tick box at the top. Use the same login information as IP4 PPPoE. This is not ticked by default. So until I ticked this option, the router was not attempting to connect using IP6. If I unticked this option, I have the option to put a different username and password if required. The point to remember is that additional configuration may be required on your router to enable it to access IP6. The other point to consider is that even if your ISP is IP6 ready, your router may not support IP6. Affordable IP6 compatible home routers only entered the market in 2010. Most routers on the market nowadays support IP6, however, not all. So if you buy a new router, don't assume it does. If you have an old router that does not support IP6, a firmware update may be available to add IP6 support. However, don't count on it. Since full IP6 support is not here as yet, how does Windows handle using both IP4 and IP6? When both are configured, this is called dual stack. It simply means both IP4 and IP6 are configured on the same system. Essentially what happens is the application will open a TCP or UDP connection. On a Windows computer with only IP4 configured, this connection will use the IP4 protocol to access the network. When IP6 is also configured, the application can choose to use IP4 or IP6. In some cases, the application may choose a particular protocol. At other times, it may just ask for a connection, and Windows will open either an IP6 if possible or an IP4 connection. This essentially means any device on the network can have IP4, IP6, or both protocols configured. This brings us to the different node types. A device running only IP4 is an IP4 node type. A device running IP6, an IP6 node. A device running both IP4 and IP6 is an IP4 IP6 node. This becomes important when using transition technology and tunneling. Transition technology is designed to help the deployment of IP6 on the network. There are many different times it may be used. For example, bridging two IP6 networks when only the IP4 network is in between. Thus, it's important to understand which node types the transition technology is designed to work with. If you are using tunneling, for example a VPN, it may only work with IP4, and thus the IP6 protocol may no longer be available. To end this video, I will perform a quick summary of what you need to do to access IP6. First, your ISP needs to be IP6 ready. Even though IP6 has been developed enough to be usable for over 15 years, ISPs have been slow to add this service to their networks. IP6 equipment, especially when first developed, was quite expensive, and a lot of ISPs did not want to replace old equipment just to add IP6 support. The next requirement is that your router needs to be IP6 ready. Affordable IP6 ready home routers have only been around for the last 5 years, but it is still possible today to buy a router that is not IP6 ready. Check before you buy. If you purchase one, also remember that it may need extra configuration to allow IP6 support. The last point to remember is that the destination must also be IP6. With limited support from the ISPs, it is no wonder that a lot of sites on the Internet are IP4 only. It will be a while before the majority of the Internet is reachable using IP6, but that is slowly changing. Remember that both Windows and Linux systems support the use of both protocols at once, referred to as dual stack. This helps with the transition process, as the administrator simply needs to configure both. They don't need to choose. In some cases, you may need to access an IP6 network. However, there is limited IP6 support between the host and the destination. When this occurs, a transition technology may be used. But this is the topic of the next video. Until then, I would like to thank you for watching and look forward to seeing you in the next video.